So today I want to center our discussion on functions. Under functions, we'll talk much of the domain. One, and then two, we'll talk about the range. And then three, then you want to categorize functions. Which one is one-to-one? And then four, are we able to know whether a function is even, odd, or maybe it's neither even or odd? And then as time allows, we should be able to talk about the composite functions now. So together with their domains, of course, together with their domains and the range. So that's our target for this lesson. So start with part one, the domain. Okay. So the domain of a function, we know that the initial thing to talk about is what values of x can we substitute in the function. So if I ask you to say, what's the domain of f of x? Before you look at the function itself, before you know what the function is, in your mind, you should say, what values of x can I put here? So that whatever will appear will be defined. You don't know yet how it appears. Okay, so but you know that when it appears, I'm looking at its restrictions. What can't be used? What should not be there? Okay, so as you wait for the function, then the function arrives and it looks like this: h of x over g of x. You see? Before again, we know what h is and what g is. The question here is, the denominator cannot be zero, because anything over zero is undefined. So we cannot allow the denominator to be zero. That's what is going to be in our domain. We will talk much of the domain of the denominator not to be zero. Now, should there be something in the root? Again, we cannot allow the root to have a negative thing. Okay? So, if h appears with a root, we have to be careful, because the root part cannot be allowed to be a negative value. Okay? So now, let's go to the examples. So the first one, f of x is equal to, now, x minus 3 over x plus 7. What is the domain of this function? So what is the domain of this function? So it's a normal fraction. So all we don't want is to see the denominator becoming 0. This guy should not be 0. Because if we allow x plus 7 to be 0, the whole thing here won't be defined. So we can't allow that. But what can make x plus 7 0? What value of x can make it 0? X equal to -7. So meaning in our domain, we'll say, okay, can actually be any x that is a real number, but it should not be -7. Because -7 is the only one that can make this thing to be undefined. Keep in mind that any number over 0 is undefined. So you shall never allow 0 to sit in the denominator. That is point number 1. Point number 2 comes with the example. F of x is equal to the root of x minus 3 over the root of x plus 7. So now we place them in the roots. There's root x minus 3. There's root x plus 7 down. What would be the domain? If I'm given a root, you cannot find the value of root -3 if you want it to be a real number. Now, all the functions in this course are real functions. There's no part when you guys have talked about complex functions. No, you've only talked about complex numbers. Now we're dealing with functions. These are not natural numbers or something. They are functions of real numbers. So in real numbers, I cannot have the root of a negative value. Such is called undefined in this case. So then I can start with the actual numerator. Say, oh, okay. Since my numerator is in the root, so I cannot have x minus 3 less than 0. It has to be greater or equal to 0. Equal to 0 because it's in the numerator. I can have 0 over a number 2. I'll get 0. Okay? Meaning that x should be greater or equal to positive 3. This information is coming from the numerator. The denominator also is saying, or even me here, I cannot be negative inside 1. 2, I cannot be 0, whether inside or outside. Because if the denominator is 0, remember in question 1, we said it can't be 0. Whether we put it in the root or not, it should not be 0. So we'll say x plus 7 should be greater than 0. We don't put the equal to because it's in the denominator. So we don't put the equal to. So we'll have x is greater than -7. Now, we need to get the intersection between solution set for x greater or equal to 3 and x greater than -7. Because these two must be used at the same time to define f. Now, if you go on the number line, here is what we see. -7 will be here if you open it and go to the right. That is -7. The other one is saying, we'll start from 3. But you can include 3, no problem. Going to the right. The intersection of the two sets means I should get the common part. So the domain for f is actually -7. Sorry. It's +3 included to positive infinity. You see? So if you are having a function that has root, but be sure that if your answer is to be correct, there is no time when you should have a negative inside the root. So be careful what you pick and how you pick it.
I have a question.
Yes, please.
How come the three, I mean the seven is not included on the number line?
And yet the 3 is included.
Yes.
So it's because the 7 is coming from the denominator, where we don't allow a 0.
Okay.
You get it?
Yes.
Okay, good. So let's put a note. But the denominator
Hello, sir.
no.
So you mean the roots must be ignored? We shouldn't consider them.
The roots.
Like, should be ignored.
No, I haven't ignored them. So what you've done is you've gone to the root and said what the root can handle. The question is not about the root. The question is about what values of x can you take inside the roots. That's a domain.
Okay.
Yes.
All right, sir. Thank you.
Okay. Okay, so let's bring in the third one. So I want to put the third one just.
Sir,
Hello.
can we repeat on the denominator before you proceed?
So we're saying the
The square.
denominator, whether square root or not, the first thing is that the denominator must not be equal to 0. The second thing is that seeing the denominator inside the root makes us say it must not be equal to a negative thing. So that's the reason why I've said x plus 7 should be greater than 0, so that it's not negative. We have removed the equal to so that it's not equal to 0. Okay, we put another one. Question 3. So f of x is equal to the square root of x minus 3 over x plus 7. Here is the situation now. We had the roots. So I'm using the same numbers so we can see the differences that are there. So already we have seen that when we didn't have roots, only 7 was disallowed, only negative 7 was disallowed here. Anything else could be used. When we have roots, we've spoken about the top root and the down root. The top root, we included the what? We included the 3. The down root, we excluded the negative 7. Now let's see what happens to question 3. So we're saying that whatever is inside the root again must be what? So here we're saying x minus 3 over x plus 7 should be greater or equal to 0. At this point, we are not talking about the numerator or the denominator. We are talking about the combined thing. The whole thing should be greater or equal to 0 because the root can handle 0. The square root of 0 is 0. So, but we know again, these are inequalities. So if I have inequalities, what do? I get a critical number. So I equate x minus 3 to 0 and get the value of x. I equate x plus 7 to 0 and get the value of x. Like that. Then we test. So we go on the number line and say, okay, let's see. Negative 7 here, 3 there. So let's pick 0 in between here. We want to use 0 to test. So we send 0 in the fraction. We will have negative 3 over 7 if you substitute 0 while there's x. So we'll have 0 minus 3 over 0 plus 7, which is equal to minus 3 over 7. So we put a minus there. So now we know that if there's a minus there, then there should be a plus here and a plus there. So we are saying this should be greater or equal to 0, is it? So meaning the domain is going to be minus infinity all the way up to minus 7. Minus 7 should not be included because it's coming from the denominator. Union 3 up to positive infinity. Not included, but included because it's coming from the numerator, where we include things. Because a 0 can only come from the numerator since it's not allowed in the denominator. Have you seen what's happening? So if the roots are separated, we see such as a domain, only one piece was a domain. When the roots are combined, we see that happen. So we should be careful when to do this and when not to do it. So always check the nature of functions you have. Do I have roots around? Whenever I have roots around, it's about the negative. It's not allowed. Whenever I have the denominator, it's about the 0. It's not allowed. If I combine the two, it's a root, it's in the denominator. So a 0 not allowed, negative is not allowed. So it should be greater than 0 only. Another situation that I'll put here is I have f is equal to maybe 3 plus x over the root of x minus 1 let me say minus 1 just, or maybe minus 4, make it a bit different. Yeah, minus 4. So we have 3 plus x over the root of x minus 1 minus 4. So the minus 4 is not in the root. And we want to find the domain. The numerator has no issues because it's not in the root. The denominator has 2 issues. 1, there's the part which is in the root, and that part must be greater than 0. So the part in the root, x minus 1, should be greater or equal to 0. This time around, the equal to can be mentioned. We're mentioning equal to because there is a minus 4. So at a time when it's 0, the minus 4 prevented the denominator from being 0. So when the root is 0, for that case, we have a negative 4. For example, when x is 1, look at the function. F of 1 is going to be what? It's going to be 3 plus 1 over the root of 1 minus 1 minus 4, which is 4 over 0 minus 4. 0 minus 4. So we'll get 4 over minus 4, which is minus 1. Like that. So we can allow it because of the negative 4. But again, so this, if we finish this part, it's saying, oh, x should be greater or equal to what? Greater or equal to 1. Okay. But again, the whole denominator must not be 0. So we come back. Say, okay, even if that happened, we are still saying this would not be 0. Okay, so this would be equal to 4, for example. That's only when they can be free, if that happens. So if we square this side and square the other side, we're going to get x minus 1 is equal to 16. So that we are saying x is equal to what? 17. So our domain now for this function is going to be x, a real number, okay, such that x is greater or equal to 1, but x is not equal to 17. Because at 17, we'll have 17 minus 1, which is 16. Root 16 is 4, and 4 minus 4 is 0. Making things very difficult for us. Because a number over 0 is undefined. So we must not expect anything thicker than this. All the questions on domains should look like this. Either I'm given a pure thing, a pure fraction, or I'm given the roots, or every fraction is in the root, the whole fraction is in the root, or I have such a kind. And that's what we had even in the test, even in test 1. What that we have in the iterations. So we don't expect new things. That's how we pick the domain. So we got the range.
Sir,
Hello.
me, I have a question. There's that one which you substitute g into f of x, then there'll be a square root sign, and there'll be a quadratic inside.
Come again.
Let's say you've substituted g in f of x, and you get square root of x squared minus 4x minus 3. Then they say find the domain.
Oh, I see. Okay, so maybe we'll see it come under the composite function. But the idea will still be the same. It's just that we're having now a product inside the root. So you want to say the product is greater or equal to 0. So now it becomes a question of inequality. Like, where does that product become greater or equal to 0? So that's why we use a number and something like that. Or maybe we can, instead of looking at the range, maybe we'll end up mixing the concept. So let's pick one of that kind. Let's pick one of that kind. So we say, well, we still want to look at the domain of maybe f of x is equal to, should I say the root of maybe x squared minus 4x minus 3. Or maybe make it plus 3 here for easy calculation. Okay. So first I'll talk about the product, and then I'll talk about where you cannot factorize the thing. So this one, so this case, we cannot factorize. So you say, okay, I still want my inside to be greater or equal to 0. So when I have it factorized, we're going to have the product is 3. So the sum is -4. So the factors are what? The factors are -3 and -1. So we factor out x, and then we'll have x -1 -3, and then x -1. So what we get is x -1 and also x -3. So then we rush into critical numbers and do the test. So we're testing at 1 and at 3. So we can pick a number. Let's pick 0 in this region. Okay. So if I pick 0 and substitute there, the first time it will give us a plus, and then a minus here, and a plus there. So that means that our domain is going to be minus infinite up to 1, not included, included union 3 to infinity. So you see all these. In fact, when you look at the issue of domains that are expected in the exam, they are sitting in inequalities. Because for you to get it, you run through an inequality. That's how the roots operate. The roots operate on greater part, greater or equal, or greater. So it's about the inequality when you put it down. So you find that you are going to use the inequalities both on finding the domain and also on just on their own as inequalities. You also meet inequalities when doing the discriminant thing, like when the roots are real, complex or something, there we also have to use them. Like you saw in the test, you were asked to check if that quadratic was going to give us real roots of what values of k. So you end up finding yourself solving inequalities. So inequalities you should watch out because There will be inequalities on their own. Inequality is under a discriminant, inequality is under domain. Okay, so the concept of domain, really, it's better we spend that time that you have spent because it's a must thing. You can't have an exam and you're not asked to find the domain. Then it's not the exam for you. Because any exam for mathematics should have the domain. And these are the key most areas of the domain. And so don't look lost when you find that they ask you this question 4. Okay. They ask you question 4. Maybe they just switch, they say, okay, 4 minus the root of x minus 1. Then you want to say, I've never seen such a thing in my life. It's here. They switch it, you work it out the same way. Okay, you see the roots are separated, when you get confused, no. Just handle them separate and get the intersection. If you have a fraction inside the root, just carry on, check it as an inequality. And find a solution in terms of domain. So that, and how many marks do we expect from there? That we expect when the combination is done, about 7 to 9 marks. So maybe they just ask you 2 pieces to find the domain there, 2 or 3 pieces. Okay, so we'll log out, wait for 10 minutes for this video to be recorded, and then we join back at this is 19, or this is 18:40. So we join back at 18:50.